The electric force between objects is hard to picture since the objects that feel the force don't have to be touching each other, just like the gravitational force. Michael Faraday in the 19th century proposed that all charges are surrounded by an electric field. Any other charge that comes into that field feels a force. The force that the objects feel depends on the strength and direction of the electric field. Drawing electric field diagrams help us view how these fields affect charges. The direction of the field lines, and the field lines are these arrows here, they show the direction that a positive charge in the field will move. So let's look at the one on the left. If we put a positive charge here, like charges repel, so we know it'll go off in that direction. So that's why the field lines are in that direction. If we put a positive charge here, it's going to be attracted to that negative charge. So the handy rule here is electric field lines point away from a positive charge and towards a negative charge. Now you might be saying, well, if I put a positive charge here, why isn't this guy repelling? Well, you know he is, but let's try and stay simple and pretend that this guy isn't moving. Okay, so this way we only have one charge moving. We can also say we will invent this thing called a small positive test charge. So when we put that little positive test charge in the field of this big one, the small one is going to move. Just like that. Now you might say, doesn't it feel the same force as the big charge? Didn't we just say that a few slides ago? Absolutely. It absolutely feels the exact same force. But when we get to physics later on in high school, you'll find that how fast it moves is going to be determined by its charge. Kind of like gravity. So let me just draw a gravity here. Here's the Earth, and here's a person. The Earth exerts a force on the person. He exerts the same force on the Earth. But since the person is so much lighter, he's the one that moves, that gets affected by the force. Same thing here. The little charge will move, the big charge will kind of stay put. We have 4 rules for drawing electric field lines. 1. Lines exit positive charges. 2. Lines enter negative charges. 3. The lines never cross. And 4. Lines that are close together represent stronger fields. So the field is stronger here, right? Because if we extended these lines out here, you can see how they're farther apart out there. Closer here, the field is stronger to the charge. Now let's put a couple of charges closer to each other. Okay, in the top we have 2 positive charges together. On the bottom, 2 negative. And we've already said that like charges repel, so how would the field lines look? Well, this is how they would look. Okay, so if I put another positive charge here, it's going to go off in that direction. And there's nobody in here. That means if I put a positive charge there, it doesn't move. It's equally balanced by the 2 forces. So it kind of looks, when you just look at that diagram, that they should be repelling each other, and yes, they are. Now let's try 2 unlike charges. We have a positive on this side, that's a positive, and a negative on the other. And what if I were to put a small positive charge here? It would get repelled from this guy and wind up over there. It gets attracted there. And if we let these 2 charges go, okay, let's say they weren't attached to anything, they would both attract each other. So notice how the field lines exit the positive charge and enter the negative charge. And if you look at this quick, it kind of looks like they're pulling each other. So these are attractive forces in here. These charges are being attracted to each other.